Okay, so I think for the first thing about integration is that why integration is difficult is because there are many ways for you to integrate. Okay, so these are basically the flow chart that will work for you. So you have to go down the list, and before you go down the next list, right, you must always check whether the previous part you already clicked. Okay, so this will be basically, so today we'll be doing this thing called the method of substitution. Okay, now I know in school, right, generally there's this thing where they ask you to memorize f prime x fx1, okay, and dx, this kind. Okay, so and a lot of other things lah. So like things like this, e fx f prime x dx. Okay, these all can be replaced by this thing called the U substitute method. Okay, what I'm gonna teach is slightly different from school. So today we'll tackle method of substitution, cancelling method. I call it a cancelling method for a reason, because you can actually substitute something, cancel off something, so that it becomes a secondary school integrable form, an integrable form. Okay, so this is the thing here. This is the theorem. It's actually a reverse chain rule. Now the reason why I need to properly write this theorem out is because not a single GC is teaching this method. Okay. Now you realize how come this method is more useful. Now sometimes when you use this method in school, most JCs like RI, Hwa Chong, and NJ, they are okay, or CJ is also okay with this method. Some JCs which are not, when the teachers are when their techniques are not strong, right, they will say, oh, this is not acceptable in A level. Okay, don't worry, I help you check already. I went to everyone in SAB, all my prof, I asked already. Okay, then if they say it's not acceptable in A level, right, then the other one, they will say, oh, it's not mathematically grounded. You don't talk rubbish. If you go and look at any integral calculator online, everyone online globally is giving you substitute method. No one in the world, right, is using this thing called f prime fx. No one. Okay, only Singapore. You know why? I don't know why. I don't know why. If you can find it, why, you tell me no why. Okay. Any calculator you found online always is use substitute method one. Nobody uses f prime fx one. Okay. So the reason why I don't like to use f prime fx method is because it's a very the list is non-exhaustive. Okay, so I will try and persuade you to see that. So essentially, most lists given in school, if not all, are not an exhaustive list. Meaning to say, if you give me your school list, right? Okay, I'll give you an example. Hwa Chong list for the F prime FX, right, is only half a page. RV one, I think is 1 page plus, and NJ one, I think is one whole page. But whatever list is given to you, right, I can always give you a counter list which is not one integral which is not in the list. Okay, I can give you, but by using the U substitute method, right, you will cover. It is actually a way for you to not use this F prime effect, so you don't need to memorize lah. Okay, so don't give an impression of needing to memorize things. Okay? It's not very healthy in math. Okay, so I hope you understand that. Now, generally, what you need to understand is this. For F prime fx method, what you need to do is just to change it to a secondary school or MF26 form. Okay, so the thing about it, right, is that all this integral you learn in secondary school. Have you learned all this in secondary school before? All this, right? This is a power function. So you add the power divided by the power. Add the power divided by the coefficient of x. This one very important. Okay, this one a lot of times students will forget. It's a coefficient of x. Okay, then ex and so on. Integrating cosine is sine ax over a, coefficient of x still. Coefficient of x, sine is negative cosine. The only thing you need to memorize is this one here, because it is not O level, and not some IP schools don't have this also. So integrating secant square is tangent, you learn in O level. Integrating cosecant square is negative cot. Okay. Then know the integrals given in MF26. This one I will explain later. So you need to know that integrating all this from MF26 give you this one on the right. Okay. Okay. So that's about it. Okay. So we look at what is a cancelling method all about. So let's try to understand this. Now, cancelling method is very simple. So let me explain to you. Okay. The first thing is to understand, right? that you use a substitution so that you can reduce into integrable form. All right. So this case here, right? What you need to do is you just let u be this guy here, the x4 plus 7. Now, then you will ask, how do I know what u to use, right? Practice, because in this thing here, this f prime fx, right, the u is actually this one. The u is this one. Okay, but the u substitute method is more superior. Later I'll show you why. Because you can use multiple substitutes to solve it, not just one. Okay, so this case here, right, what you do is, right, you let this be the u. So what we do is 4x cubed. We change this to u4, right? Then if you change it to dx, need to change to du lah. Okay, because now I'm integrating with respect to u. So you put a du here. Just remember to divide by its derivative. So this will be 4x cubed. This will be 4x cubed here. Okay, so you cancel it out. This guy here cancel. Do you see that when you cancel this out, what happens here is it becomes a secondary school integral. Okay, becomes secondary school integral. So this guy here will be u5 over 5 plus c, and essentially this guy will be 1/5 x4 plus 7 by 5 plus c. You sub back your u back inside. Sub back your u. Okay, so essentially, you replace the u, just divide by its derivative. Then you ask why lah. So I'm gonna do some it's very simple one. So it's because when you du dx here, this is 4x cubed, right? Then dx will just be du over 4x cubed. So this case here, you just sub inside here. Okay. Now, the dx is du over 4x cubed. Okay, some schools say, oh, you cannot write this in your exam. Will penalize you. Okay, this one here. Erase it lah, erase it. If your school don't allow you to write, penalize it. But this one is commonly found in Cambridge or any university calculus 1 textbook. Is all in the university textbook. All I'm saying is, if Cambridge can put it in a university textbook, you think that A-level Cambridge, they won't accept? You think, push come to shove, would I choose your school notes or choose the Cambridge calculus textbook? You tell me. Of course, you choose the school. Of course lah, kidding. Choose the Cambridge textbook lah. They are more expert, right? But doesn't matter. Okay, I'm not here to say who is right or wrong, but we clearly know who is right or wrong. But you just understand that this one is commonly found in university textbook. Then can already. Then whatever your teacher say, just okay, just not okay. Can. When you're Rome, do what the Romans do. Now, then the next thing is same thing. Okay. You will understand what you let this be your u, right? You see this, you eyeball this one. You can cancel the one on top. So this is x squared plus 4x plus 6, right? This will be x plus 2 over u du. This will be, just put the derivative. So it's 2x plus 4. You realize this is just a multiple of the other one. You can cancel off. This is 1 over 2. This becomes an integrable form, which is what you learn in secondary school. This is half ln u plus c. And this guy here, what we'll get is actually half ln x squared plus 4x c 6 c. Okay? Is it? Okay. So say similarly with this guy here, if I were to sub this as my x, my u, I can cancel the x in front. Okay, the top. So this guy here, u equals to x squared plus 1. In fact, there are two ways of doing this. You want me to show you how? Method 1, you let your u be x squared plus 1. Okay, you see this one, So then you appreciate why this way would work. So this is 2x. Cancel. This will be half EU du. This will be equals to half EU plus c. This equals to half e x squared plus 1 plus c. Okay. Then after that, method 2, u equals to ex squared plus 1. Okay, one can use two methods here. So oftentimes, this one will be xu du. So if I were to differentiate this, remember chain rule. The bottom, just put the derivative ex squared plus 1 times 2x. Cancel it out. This will be half ex squared plus 1 du. Now, take note, guys. The integral sign, the variable cannot move out of the integral sign. Okay, so if it's out of the integral sign, then you will run into the law. You're committing a crime. So don't do that. Only the constant can bring out. So this guy here, remember, you're integrating with respect to u, right? So you sub back your u inside lah. This is your u. See that? So you just make everything in u. So this is u over u du, which is half du. Half 1 du. So this is half ex squared plus 1 plus. Okay. So this is how you use cancelling method proficiently. Anyway, we're just gonna practice out. Today we're just gonna practice the cancelling method until you know that the cancel culture first starts in calculus. And yeah.